Hello everybody, welcome to the channel, and in today's lesson we'll be talking about solving triangles, which is a topic you're required to know for your GCSEs and extended IGCSE mathematics. Anyway, so basically in geometry, when we talk about a triangle, it has 6 important qualities that we need to know about. For example, let's say we have a triangle, we need to know its side lengths, that I'm going to call A, B, and C. And also the angles, which I'm going to call alpha, beta, and gamma. For example, if I draw this triangle right here, and let's say this length is 4 units, and this length is 5 units, and this length is 30 degrees. This is already enough information for you to know everything about this triangle. You can calculate this angle, and this angle, and this side length. Alright everyone, so in order to solve triangles, there are 3 important theorems that you need to know about, and those are: firstly is the fact that the angles in a triangle add up to 180 degrees. Secondly, the second and the third one are the more important ones you need to memorize. And the second one is the law of sines. That's right. Now, in a triangle, let's say A, B, let's say it has side lengths A, B, and C. This corresponding angles of alpha, beta, and gamma. Now, the law of sine states that the sine, the side lengths, and the ratio of their corresponding angles is equal for any side of the triangle. So the length A divided by sine of alpha is equal to length B divided by sine of beta, as well as equal to the length C divided by sine of gamma. Now let's go over a quick proof of this theorem. So let's say you have a triangle. Again, side lengths A, B, and C. Sine this angle is going to be alpha. So what I'm going to do is, and let's say this angle right here is gamma. Sure. Now what I'm going to do is I'm going to draw the height from this point, and let's get a different color. So this angle is going to be 90. Yes. This angle is going to be 90 degrees, and so is this angle. So the trigonometry tells us that this length right here is equal to A times sine of gamma. But looking at this side, it tells us that this right here is equal to C times sine of alpha. And doing some algebra, we get that A over sine of alpha is equal to C over sine of gamma. And you can do this for all sides, and you will get the proof for the law of sines. Alright everyone. So the third theorem that you need to know about for solving triangles is the law of cosines. Just going to write here. Yes. So in a triangle, let's say like this. Let's call side lengths A, B, and C. and I'm gonna have, and let's say the angle between A and B is theta, and the law of cosine states that the length the length C squared is equal to A squared plus B squared minus 2A times B times the cosine of theta. So this right here is the law of cosines, and the proof of this is not too complicated. Let's draw again. Hold on. Yeah, let's draw the height from this side length, and this angle is going to be 90 degrees, and so this. Now, trigonometry tells us, I'm going to use a different color for this. Trigonometry tells us that this side length right here is A times cosine theta, and this side length right here, this the length of our height, is A times the length of our height is A times sine of theta. So you see that this length right here is also B minus A cosine theta. And from the Pythagorean theorem, you see that C squared is equal to the length of this squared, A squared sine squared of theta, plus the length of this squared, which is B minus A cosine theta squared. Now let's expand this algebraically. You see that C squared is going to be A squared sine squared. I'm going to write sine in green. Plus B squared minus 2AB cosine theta plus A squared times cosine squared of theta, which I'm going to write in green. Now, as you can see, there's a cosine A squared times cosine squared theta, and A squared times sine squared theta, and cosine squared theta plus sine squared theta is equal to 1. So these two cancel out. I'm going to write that in there. These two cancel out, and what we get is C squared is equal to A squared from here plus B squared minus 2AB cosine theta. Now, it's an important fact to remember that when theta equals 90 degrees, cosine theta equals 0, meaning that C squared is equal to A squared plus B squared, which is exactly this Pythagorean theorem. When this angle is 90 degrees, C squared is A squared plus B squared. Alright everybody, now let's start using some of these theorems to solve some triangles. So, as an example, let me draw a triangle. And we'll say this angle is, let's say, 66 degrees. And this angle is 58 degrees. And this angle is 6 units. Now, this is known as a angle-angle side triangle. And the reason being, we know two angles and we know a side. Now, in order to solve this, first of all, let us calculate this angle right here. And that's simply going to be 180 minus 66. Minus 66 minus 58. Which is 56. So we see that this angle is 56 degrees. Now I must say that this topic is a very calculator heavy topic, and you need to know how to use your calculator, especially the sine, cosine, and the inverse sine and the inverse cosine functions. Anyway, so now that we know this angle, well, let's call this side length A and this side length B. Now we know that we know that 6 divided by the sine of 66 degrees is equal to A divided by sine of 56 degrees, which is equal to B divided by sine of 58 degrees. And using this and a calculator, we can calculate the values of C, A, and B, or A and B. So, for example, A here would be 6 times sine of 56, sine of 56 divided by sine of 66, which would give us 5.44, approximately 5.4. Yeah, approximately 5.44. And similarly, B would approximately equal to 6 over sine of 66 multiplied by sine of 58, which is approximately equal to 5.57. So as you can see, in an angle-angle side triangle, we can use the law of sines to calculate all the side lengths. Alright everybody, now let us tackle the case where we know three sides of the triangle but no angles. For example, let's have the case where, let's say, this side length is 3, this side length is 4, and this side length is, say, 5.5. Now, in order to solve for these angles right here, we need to use the law of cosines. So, for example, let's say this angle right here is alpha. We know that 5.5 squared is equal to 3 squared plus 4 squared minus 2 times 3 times 4 cosine of alpha. And from this we can get that this right here is equal to 24, right? And this right here is equal to 25. So we see that if you just quickly rearrange some stuff, you see that 24 cosine of alpha is equal to 25 divided by 5.5 squared. No, it's not. Minus 5.5 squared. Right? Yes. And we see that if we divide both sides by 24 and apply in the inverse cosine to both sides, we see that alpha is equal to the inverse cosine of 25 minus 5.5 squared over 24. We can put this in a calculator and we will get approximately, what will we get? So let's see, we'll get the inverse cosine of 25 minus 5.5 squared divided by 24, which is going to be equal to approximately 103 degrees. Let's say. So 3 significant figures. Now, all right, and we can do a similar process of using either the law of cosines or this time the law of sines to calculate the other angles, and hence we can solve the triangle fully. Alright everybody, now let us tackle the case where the triangle is a side angle side triangle. In other words, we know two sides and the angle between those sides of a triangle. So for example, let's have a triangle which this side length is 3, this side length is 4, and this angle right here is, let's say, 41 degrees. Now let's say this length right here is A, and in order to calculate A, we can use the law of cosines. We know that A squared is equal to 3 squared plus 4 squared minus 2 times 3 times 4 times cosine of 41 degrees. And of course we can solve for A using by taking the square root of both sides. And now we can plug this into the calculator to get us the side length A. And from then on, we can again use the law of cosines to calculate this angle and this angle, which would solve us the side angle side triangle. Alright everybody, now let us consider the final and the most tricky case for solving triangles, which is the side-side angle case. This is when we know two sides of a triangle and we do not know the angle between them, but we know another angle. So for example, let me draw a triangle like this that will have side length B, A, and let's say an angle alpha. Now the reason this here is a tricky case is that there are actually two triangles that have that satisfy this case. If we draw this line right here, such that this line is, let me draw that another color. If you draw this line right here, such that this line and the length of this line is also A, meaning that this right here is an isosceles triangle, and this angle right here and this angle right here is the same. Notice we got both this inner triangle right here and this outer triangle is also are the same side angle triangles because they have side lengths B, A, and an angle alpha that is not between them, looking at A. Now this means that when solving for side angle triangles, you can actually get two answers, and you have to select you can get two answers for this angle right here, which could be this angle or this angle, and you have to be careful on which one to select. For example, let us give an example. Let me give an example. We'll have, let's say, side length 13. No, let's say it's 13, 8, and 31. Let's say 31 degrees right here. Now, in order to solve this triangle, well, we can do it by firstly calling this angle alpha, let's say, and we know that using this law of sines, we know that 8 over the sine of alpha is going to be equal to 13 over the sine of 31. And similarly, if we call this, if we find alpha, we can also find beta, which is this going to be this angle right here. However, we need to be careful because again, if we draw this line right here, such that this side length is also 13, the alpha value we find could be this angle or this angle right here or this angle right here. And how we distinguish between them, well we're gonna let's see. So if we put this value, if we solve for alpha right here, we're going to get that sine of alpha is going to equal 8 times sine of 31 degrees over 13, right? So I think so, right? Yeah. And to solve for alpha, we just need to take the inverse sine of this, and we can do this in the calculator. Now, doing this, we get, let's see, we get 8 sine of inverse sine of times 31 divided by 13. Hold on. We get approximately 18.5 degrees. So alpha is approximately 18.5 degrees. But notice that this angle right here is an obtuse angle, while this angle right here is an acute angle. So the angle we have found is this angle right here. If you are being asked for the obtuse angle, so this angle right here, what you need to do is actually subtract, let's call this angle, not actually, let's call this angle not alpha, but something else like a beta or beta. And beta is approximately going to be equal to 180 minus 18.5 degrees. Alright everybody, before we start solving some questions, there's also one other theorem that sometimes comes up in questions, which is calculating the area of a triangle using an angle and the side lengths touching it. So in a triangle, if we have this angle be theta, and let's say this angle is A and B, we know that the area of the triangle is going to be equal to 1/2 times A times B times the sine of theta. So the area of the triangle is this. Alright everybody, now let us begin with solving an example question right here. Alright, so it says that the area of a triangle is 61.5. So let's us call this angle theta. And we know that the area of the triangle, so 61.5, is going to be equal to 1/2 times 12.9 times 9.8 times sine of theta. Now solving for theta, we get that theta is going to equal the inverse sine of, what is it going to equal? Inverse sine of 61.5 multiplied by 2 divided by 12.9 multiplied by 9.8, I think, right? Yeah, alright. So now that we know this value of theta, now here's an important point. It says that the angle BAC, so theta is acute. If it said that it's for obtuse, then we would need to calculate this angle right here would be 180 minus theta. However, it is acute, so we can just leave it as this. Now it says that work out the length of BC, and to do this we can use the law of cosines. So simply let's call this length x. You know that x squared is going to equal 12.9 squared plus 9.8 squared minus 2 times 12.9 times 9.8 multiplied by the cosine of the value theta. Now we can solve for x here by simply taking the square root of both sides. And now all that's left is to just put this expression into your calculator. Now do note that is a long expression, and make sure to double check your answers always. And putting that in, we get that x is going to approximately equal 14.3 centimeters. To 3 decimal places. Significant figures. All right.